Hey guys, Mr. Betts here. So, half of calculus is what's called differential calculus, and that's what we've been studying so far. So, calculus looks at rates of change, and so we find rates of change in graphs of functions as slopes of tangent lines. And then the other half of calculus is called integral calculus, and it has to do with the area problem. So, the area problem uses a notation that's called a definite integral. So what I want to do real quick here is introduce you to the notation of a definite integral. So this expression right here is what's called a definite integral, and it represents the area of a function between the function and the x-axis on some interval. So the upper limit here is going to be the right endpoint of the interval. The lower limit here is the left endpoint of the interval. So those two indicate where we start and where we stop along the x-axis. So this differential right here, we've seen differentials in differential calculus. So that differential tells us which axis we're taking the area between, so between that and the function. And then this is the function right here. So this symbol right here is called the integral symbol. It's an elongated S, S standing for sum. So if you take an S and you just stretch it out, we get the integral symbol. And so this as a whole is a definite integral that represents the area between f of x and the x-axis between x equals a and x equals b. So lots of information here. There's really four pieces of things that we use here to get the area, and these are the four boundaries essentially. So we get a vertical line at x equals a right here, a vertical line at x equals b right here, a horizontal line, which is the x-axis here, and then f of x is more or less a horizontal line, but it's a curve in this case. And then that represents this shaded area right here. So this is again called a definite integral, and the goal of integral calculus is to compute the area indicated by any particular definite integral. And we're going to start getting into that in the lessons in 6.2 and moving beyond that.